Hello guys and welcome back to my channel Interview with Bunny, and today we are back with another video on system designing, and the topic that we will be discussing today is called the proximity search. So very honestly, this is not an interview question that you will directly receive during your technical interview. Means your interviewer won't be asking you to implement a proximity search. Rather, while you will be designing some other problem statement there to solve that problem, there you need to know how the proximity search algorithm actually works. So let's first understand that what this proximity search algorithm and what is the use case that we can solve by this algorithm. So if you have gone through my previous videos, then you must be knowing that I have already discussed about this proximity search very briefly during my last couple of videos. Means while we were designing the hotel booking application or while we were designing the Zomato of the Swiggy apps, there we have discussed about the proximity search algorithm to find out the places nearby a particular location. So let's see what are the most popular algorithm that we normally discuss during our system designing interview, and based on your use case, which one you should use to solve a particular problem. So as I have already told you in my previous video, there are 3 to 4 types of algorithms or the pattern with the help of which we solve this problem. And the most commonly used algorithms are number 1, the quad tree, number 2, the geohashing, number 3, the Postgres solution, and number 4, the Elasticsearch. So let's now discuss in detail all those 4 approaches, and let's see based on the use case which one should we use at what condition. So let's first start with the first one, and that is the quad tree. So if you go through the system designing videos that are available mostly on the YouTube, you will find that most of the videos discuss about the quad tree whenever they are doing a proximity search. So very frankly, during your interview, it is very easy to explain a quad tree to the interviewer. But in the real world application, this quad tree is very difficult to implement and very difficult to maintain. So let's first understand that what is a quad tree and how this is implemented, so that it will be easy for you to understand that what can be the pros and cons of the quad tree and why you should avoid to give a solution of the proximity search based on the quad tree. So let's first see what is a quad tree. So just like a binary tree, quad tree can have 4 leaf nodes. Means for a binary tree, obviously you know it can have only a left child and the right child. But in case of the quad tree, we can have 4 children for a particular parent node. So that is why it is called a quad tree. So what we actually do in the quad tree is like we divide the entire globe, means the entire world map, into 4 quadrants. So here if you see, this is the entire world map. And this entire world map is divided into 4 quadrants. So here this is the first quadrant, this is the second, this is third, and this is the fourth. So on the first iteration, the world map is divided into 4 quadrants. So this is the first iteration. Now what we do, again a particular quadrant is get subdivided into again 4 quadrants. So here if you look carefully, this northwest quadrant got divided again into 4 quadrants. So in this way, we keep on subdividing each quadrant into 4 partitions until and unless we reach a particular area or a particular data point. And the way we subdivide this entire globe into 4 quadrants is with the help of this quad tree. And here you can see, if you imagine that this is the world map, so here if you see, these 4 nodes consist of the 4 quadrants of the world map. Similarly, this node gets subdivided into separate 4 quadrants, and in this way, it will keep on recursively dividing itself into small and small groups until and unless we reach a particular leaf node. So for example, a leaf node can be a single restaurant, or it can be a group of restaurants that are located quite nearby. So that is how the quad tree gets subdivided into smaller and smaller trees. So you can easily imagine that if we are holding a particular restaurant or a particular group of restaurants in the leaf node of our quad tree, then how many levels of nodes that are present in the entire quad tree that we are defining to represent our world map. So that is a huge quad tree with thousands and thousands of levels of the nodes that are present in a particular quad tree. So that is how a quad tree is designed to represent a world map. So I hope this is clear that how a quad tree is designed and how we keep the information of the restaurant in the quad tree. So here, for example, this is the last quadrant of the quad tree, and this quadrant can hold one or two restaurants or the hotels that are located very nearby. And this is how the entire world map gets subdivided into 4 quadrants to hold the relevant information that we need to design our application. Now, since you have got a brief understanding that how we represent our entire global structure into a quad tree, now let's see what can be the pros and cons that we get with this implementation. So here, if you look carefully, there is a major drawback while designing the quad tree, and that is the uniformity of the data. So what happens, like whenever we are designing a quad tree, we go with the assumption that all the restaurants or the hotels, means all the data points, are uniformly distributed across the globe. And if that is the case, then we will be having a balanced quad tree. But in the real world, the scenario is not like that, because it is quite obvious restaurant or the hotels means the relevant data point cannot lie uniformly across the globe. Because obviously, if you see the entire world map, so here obviously we cannot expect a hotel or a restaurant in this water area. Also, we cannot expect a hotel or a restaurant in Greenland or in Antarctica. So the data points are obviously not uniformly distributed across the globe. And that is why this dividing of the quadrant is not uniform across different locations. So actually what happens, like we get a quad tree something like this. So here, if you see, if I assume this is one of the quad tree, so here you can see the entire world map is first got divided into 4 quadrants. So this is the first half and this is the second half. Now in the second iteration, what we are doing, we are again subdividing the next quadrant, means this one, into again 4 partition. So this will be 1 partition and this will be again 1 partition. Next, on the next iteration, what we are doing, we are again subdividing this quadrant into 4 partition. Means 1 partition will be here and another partition will be here. But if you look carefully, there is not a single hotel or restaurant or the data point that lies on these 3 quadrants. Means these 3 quadrants cannot be subdivided any further. Means these 3 will be the leaf node for this entire quadrant. But the quadrant that we have over here can be again further subdivided into multiple levels, because here if you look carefully, there are further restaurants that are located nearby. So to reach to that precision, we have to again subdivide this entire quadrant into 4. And in this way, you can easily understand that this distribution of the quadrant is not uniform across the entire global area. And that is why what happens is, like the quad tree that forms in a global level is not properly height balanced. So one of the region which is quite densely populated, that regions get subdivided into thousands and thousands of subdivision, and thus the height of that tree becomes quite huge. Wherever the places which are less populated, there the quad tree does not get subdivided. So this is actually a main problem of the quad tree. So let's understand that why this unbalanced height of the quad tree can be a major critical problem for finding the relevant data point near to a particular user. So let's take an example of this quadrant. So over here you can see this is how the quadrant is subdivided into places. And let's take an example. These are the data point where the restaurant or the hotels are placed. Now let's take an example that you are a user who is sitting somewhere near to this point. So this is the position where you are sitting. Now the problem statement is you have to find out all the restaurant or all the hotels that are present in a 5-kilometer radius. So that is the problem statement. So for example, this is the 5-kilometer radius that you have to look for. Now, here just looking at the diagram, you can easily understand that these are all the relevant points, means all the restaurants that should come in your search result. But to get that information in the search result, there is a lot of things that you have to do in a quadrant. For example, here you are located in this quadrant of this quadrant. And obviously, since there is not a single restaurant that is present in this quadrant, what we have to do, we have to see what will be the parent of this quadrant. So for example, here you are. This is one of the quadrant of the quadrant, and this is where you are located. So this represents this one. Now what we have to do, now since no restaurant is present on your quadrant, we have to move above, means we have to see what is the parent of your quadrant. So we have to go above to one level. So this is your parent quadrant, and here you have to search from this parent quadrant, means right now you are over here, and within this parent quadrant you have to go to each of its child quadrant, and you have to see whether the restaurants are present to that or not. So here you can see, if I go to this quadrant, means we come to this quadrant, and here you can see we have two restaurants over here. So two restaurants will go as a search result. Again, we will go to the next one, means this one. Here there is not a single restaurant present, so it will go as 0. Again, here there is not a single restaurant present, so this will go as 0. So from this entire quadrant, two restaurants got listed over here. But if you look carefully, these two restaurants are not sufficient. If you look carefully, there are a few other restaurants or the data points that are present nearby to this location. So what we have to do, again we have to go to the parent quadrant of this one. So since we have already done searching this entire quadrant, we have to again go back to its parent one. So from here it will again go back to its parent one, and this parent obviously will have again the 4 quadrant. So right now we are at this point. So here this is nothing but this node. I hope this is clear. Now again from this quadrant, we have to again see that what are the leaf node or what are the restaurant that are present over here. And in this way, we have to keep on iterating over each and every children of each and every node. And we have to find out all the relevant restaurants or the relevant hotels that are placed within the 5-kilometer radius of this user. So I hope you are clear with this concept that though it looks quite simple over here to represent and divide the globe into 4 quadrants, but to find out the nearby location or each and every quadrant or in the neighboring quadrant is quite a time consuming and a tedious approach. And that is why we do not prefer to use a quad tree to solve any real world problem. Moreover, since a quad tree is not a database, rather it is a data structure, so obviously to store that data structure, you also need an auxiliary space in the memory. So what happens is, like, whenever all the restaurant on the hotels comes to your application, you have to first create a quad tree for this entire application. And you can easily understand that if you have millions of listings of hotels and the restaurant in your application, what can be the total size and the depth of the quad tree that you have to maintain. And obviously, whenever a new restaurant is getting added into a database, obviously you have to build that quad tree again so that it falls in the correct partition. So it is more or less like an AVL tree or like a binary search tree, means whenever you add a particular node to a binary search tree, you know that it gets rebuilt so that it can hold this property. Similarly, over here in the quad tree, whenever a new data point comes to our database, we have to recreate the entire quad tree or the entire quadrant of that quad tree to accommodate that data point. So that is a very time consuming process, and that is a very tedious one to implement. And also, since whenever you are designing a hotel booking application or you are designing something regarding the proximity search, you have to maintain 2 to 3 replica set of this data structure. One is the read copy and another is the write copy. Means the read copy is the final copy from where user will be searching the data, and the write copy will be the one where you will be updating the latest change or the latest addition of the hotels in your application. So in this way, you have to maintain at least 2 copies of your quad tree in your server, and that is why it is very difficult to maintain the quad tree in memory, and it is very difficult to search a particular location in a near real time. That is why during your designing, try to avoid the quad tree approach for implementing the proximity search. I hope you got a clear understanding that how we implement a quad tree, how do we store a quad tree in memory, how we search a particular nearby location within the quad tree, means how here we are parsing this entire tree to find out the relevant information and all these things. And since you got an idea that this is a quite a critical approach to implement in the real world application, so try to avoid this quad tree during your system designing interview. Rather, it is better to go with a R tree than a quad tree for the implementation of the proximity search. Now, what is an R tree? So R tree is nothing but an enhanced version of the quad tree which actually solves the problem of finding the neighboring nodes for a particular location. But that is right now out of scope of this video. Now let's see what can be the other approaches of implementing a proximity search. So the next proximity search algorithm that we will be discussing is number 2, the geohash. So let's first understand that what is this geohash and how it is better than quad tree for implementing the proximity search. So the geohash implementation is more or less similar just like the quad tree. So here also we subdivide the entire world map into 4 quadrants. So here you can see this is the world map which we have divided into 4 quadrants. Means the northwest is 0, the northeast is 1, the southwest is 2 and the southeast is 3. And in this way, we divide the entire world map into 4 quadrants. And from here, what we do? Again, we subdivide into grids. And that is, here you can see this 0 got divided into 0, 0, 0, 1, 0, 2, 0, 3. Similarly, this 0, 0 again gets divided into 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3. So in this way, each and every quadrant gets subdivided and assigned with a numeric integer. So it is more or less the same way by which we distribute the entire world map into quadrants. So both the approach are more or less same. So here also you can easily assume that once we keep on subdividing a particular quadrant into smaller and smaller grids, this number will become a huge integer. And to represent that huge integer into a meaningful form, what we do a encoding called as a base 64 encoding. So let's see how it is implemented in real life and how it is helpful to solve the real world problem. So here if you look carefully, this is how the geohash indexing actually works. So here you can see this entire world map got divided into this many quadrants. Now let's take an example. I want to target and find the geohash index of a particular location of Bangalore. So what I will do? First, I will target that where India is located. So India is located in the quadrant T. So I will go to the quadrant T. Now here you can see this quadrant T again got distributed into multiple sub-quadrants. Now what we have to do? We have to find out Bangalore. So here if you see, D is the quadrant where we can locate Bangalore. So I will move to quadrant D. And as soon as I move to quadrant D, it again recursively got subdivided into multiple quadrants. So right now our Bangalore is located at quadrant R. So let me click on R. So here you can see it again got subdivided into multiple pieces. Now let's take an example. I want to find out an electronic city that is present over here at Bangalore. So I will click on 1. So here you can see again it got subdivided into multiple quadrants. Now let's take an example. I want to go to this Kormangla area. So let's click on W. Now within this quadrant, you can already figure out that I can already see the lakes and the buildings that are over here. So let's go a bit deeper. So let me click on K, and within this file, I want to see the passport office. So let's click on 9. And here let's click on 4 to get the McDonald's restaurant that is present over here at Kormangla. And here you can see I have subdivided and came to this point. And here to get the location of the McDonald's that is present over here at Kormangla, this is the string that I need. So this is nothing but the geohash index of this particular location. So here you can see we have came up from the world map to this minute level of a particular store, and this is only a small representation that we need. And here just look carefully, this MACD and this Zudio are present quite nearby, maybe within 100 meters apart. Now look carefully what happened to this index while I move from this MACD to this Zudio. So if I just move to this Zudio from MACD, you can see only a single bit that got changed, which means that this is the parent node of this entire location. And if I want to find out all the nearby location, only thing that I have to do is only have to change this single bit to find out all the location that are present or all the restaurant that are present nearby. So here you can see, with the help of the geohashing, finding the nearby restaurant or a nearby location is damn easy. I hope this is clear that how this geohash works in the real life. I will share this link so that it will be easy for you to go through each and every possible location and find out that how this indexing is getting created and how we can identify a particular location with the help of this index. So what happens is, like, whenever a new restaurant comes to our application, once the restaurant owner or the hotel owner onboard themselves in our application, they obviously will give the latitude and the longitude, means the exact location of the restaurant. And based on that latitude and longitude, we can easily compute the geohash location of that corresponding hotel or restaurant. And based on that geohash, now it is very easy for us to find out any nearby restaurant or the hotels or driver that are present maybe within that 5 km radius or a 10 km radius. So believe me, this is the best approach to implement the proximity search in the real world application. Now the question might come that how we can convert our latitude longitude into a geohash. So for that also pre-built libraries are present. Let me give you one more example. So here you can see this is another website where you can simply find out the geohash index of a particular location. So here what you have to do, you have to simply give the latitude and the longitude of your place, and you have to give the level of precision that you want to do. Means the more precision you give, more amount of subdivision within the grid will created and the length of the geohash will increase accordingly. Let me give you an idea that what this precision level talks about. So here the precision level is nothing but this one. So means if you are interested in getting all the location that are present in a 5 km radius, you have to go with a precision level of 5. If you want to go a bit deeper, means you need to get all the restaurants that are present within a 500 meter, then you have to go with something with precision level 6. So based on the level of precision that we have, the distance of the quadrant is changing accordingly. So here in the geohashing with the level 9, you can pinpoint a particular location with just a 5 meter radius. So this is actually the precision level that we can achieve with the help of this geohashing. So I hope this is clear that why we should go with this geohash mechanism. And obviously right now you know that finding the neighboring nodes with the help of the geohash is also quite simple, because while we were discussing about the quad tree, what we were doing, we were backtracking the parent level one at a time. But here in this case, we are not traversing any tree. So we are just changing one bit of the string to find out the neighboring location. So let me just also give you a brief introduction that how you should save this information in the database and how with the help of the code you should look for the neighboring nodes. So here if you see, this is a schema structure that you can use to store the information of the restaurant. So here you have the ID of the restaurant, the name, the latitude, longitude, and also the geohash that we have generated from here. So this will be the schema structure to save the information of the restaurant. Now to find out all the nearby restaurant, what we have to do, we have to simply write a query something like this. So here you can see it is a simple SQL query. Here what we are doing, since we know that all the neighboring nodes or neighboring restaurant quadrant will be differ by one character. So here we are searching it like this. So here we have a wild character at the last, and this is the center or the location of the user from where we want to search all the restaurant. So I hope this is quite clear that with the help of this simple approach of this geohash, how you can implement a proximity search. Now let's go to the third way of implementation, and probably one of the simplest way of implementation, and that is using a Postgres database with a GIS extension. So here, as you know, Postgres is nothing but a database, and GIS extension is an added extension that you have to install on top of your database so that you get the added benefit of all this geohashing and searching and all this logic by default by the database. So let's see how it is done. So here, if you look carefully, whenever you have installed a GIS extension on top of a Postgres database, you get some added libraries, something like this, like geo from text. And this type of libraries helps us to do the proximity search and all these things by default. So what we do, once a restaurant comes to our application, we simply insert the latitude and the longitude of that restaurant with the help of this command. And thus, once that information is present in this location field, searching all the restaurants that are present nearby is quite easy. And to do it, what we do, we simply write a SQL query to perform that activity. And this is how the query looks like. So here you can see this is a simple select query from this restaurant database, and here we got an additional library called as dwithin. And with the help of this, what it does, like, it checks that within this location field, what are the restaurants that are present within a 5 km radius. And with the help of this simple query, you can easily find out all the relevant information that you need to build your proximity search. So I hope you already got the idea that implementing a proximity search means solving that type of problem is quite easy with the help of the geohash as well as with the help of the Postgres solution. Now the last and the final way to implement the same concept, and that is with the help of the Elasticsearch. And believe me, implementing with the help of the Elasticsearch is damn easy. It is just like plug and play things to find out any solution, because as you know, Elasticsearch is highly capable to do any type of searching operation on a particular database. And here also, Elasticsearch comes with the added geolocation searching, means you do not have to also install this extension into your Elasticsearch. All these things comes by default within your Elasticsearch algorithm. Now, since we have discussed all these four approaches, number one, the query, number two, the geohash, number three, Postgres solution, and number four, the Elasticsearch, let's now discuss that which approach you should take during your designing. So very obviously, since this query is quite complex thing to implement and very hard to maintain, simply try to omit this query during your designing phase. Next, the three approach that comes is the geohashing, the Postgres, and the Elasticsearch. Now, among these three, if you are only concerned about finding the location of a particular attribute, means for example, you want to find out list of all the drivers near to your location, means for example, when you are designing applications such as Uber, Rapido, all these things, then simply go with this geohash implementation, because this is very much powerful tool to do all this proximity search algorithm. But in case your problem statement is a bit different, means you have to implement a searching logic not only just by location but also with the help of the text, then go with this two solution, that is with the Postgres and with the Elasticsearch. So for example, whenever you are trying to search a particular restaurant with the help of the name, so obviously there at that time this will not help, because at that time we have to go with the fuzzy search algorithm, means by which we can do a textual search. And whenever you are going with the textual search, you can either go with an Elasticsearch or you can either go with the Postgres database but with another extension called as a fuzzy search extension. So let me write it over here. So this is the extension that you need to install in your database, that is a fuzzy string match. And if you have both the fuzzy string match and the GIS extension both installed in your Postgres database, then this Postgres solution and this Elasticsearch are more or less the same. So you can simply go with either the Postgres solution or with the Elasticsearch approach. I hope now you are clear with that how you should implement a proximity search algorithm during your interview. And as I have told you, this is not a direct question that you will face during your interview. Rather, while you will be designing something else like designing a Uber or designing a restaurant application, there you have to discuss in detail that how you should implement a proximity search algorithm to find out all the nearby location or nearby driver to a particular user. So I hope you have thoroughly understood this video, and if you have found this video useful, do not forget to like, share and subscribe my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you on our next video where we will be solving another problem on system designing. So see you on our next video. Thank you.